Hello students, in the previous video we have seen what is potentiometer and we have seen one of the application of potentiometer to compare the EMF of cells. In that also we have seen two different methods. First method is by individual method or by parallel method, and the another method was in series method or sum and difference method. In today's video, we are going to see another application of potentiometer, and that is to find out the internal resistance of the cell. So what is the internal resistance? We have seen in earlier video also. So suppose here you can see here is a battery with EMF epsilon 1 and small r is the internal EMF. This means if we attach this battery, this much resistance is automatically get added to this circuit. So we have to find out using the potentiometer. So you can see in this diagram that here is another battery which we have with known EMF, and there are two keys K1 and K2. So first of all, the K2 key will be open and we will close K1 key. So the current will flow from this circuit, but it will not flow from PTSQ. This will be off. So for this circuit we will get some null point. So at that null point we will get the potential is equal to K into L1. We have seen in earlier video what is the potentiometer principle. So in that we have seen that how we calculate the potential difference or the EMF. So we can get V is equal to I into R. So we will get some voltage across this terminals A and J. So we will get V is equal to A into R. Now close this key, so the current will flow through this circuit, and if this current is I and we consider this loop PTSQ, this loop PTSQ, and again at P, it will end at P. So if we consider this loop, we can write an equation using Kirchhoff's law, that is epsilon 1 is equal to I into capital R plus I into the internal resistance, this small r. So I into R, or we can write this is exactly equal to I, we can take common and then capital R plus small r, external resistance plus internal resistance. If we have recorded the length at which the galvanometer shows null deflection, let's call this is L2, because we will call for epsilon 1 we will call the length is L1. So as we have studied in earlier video, we can take the ratio as we have taken to compare the EMFs. So we can take the ratio epsilon 1, I will write here epsilon 1 divided by V, and that will be equal to capital I, that is current, into capital R plus small r, that is external resistance plus internal resistance, divided by I into R. So this capital I will get cancelled because that is common on numerator and denominator. As earlier we have discussed, epsilon 1 is directly proportional to the length L1. So let's say K into L1. I will not write K here because it will get eventually cancelled like I here, and V2 and V will be directly proportional to L2. So epsilon 1 will be equal to K into L1 and V is equal to K into L2. So K and K will get cancelled. So I have written here directly L1 divided by L2. Now if we solve this equation, R plus small r divided by capital R is equal to L1 divided by L2, we can find out the internal resistance. Or if we know the values of capital R, and we will measure small l1 and small l2, that are the lengths of respective null point. Then we can calculate the small r. I will write it here. Small r is equal to capital R into bracket L1 divided by L2 minus 1. So if we solve this, we can get the internal resistance of this battery. There are other applications of potentiometer also there. One important is voltage divider. So this means we can distribute the voltage at different lengths using the potentiometer. Then it can be used in audio control devices and sensors. So we will not see this in depth. So we are not going to see this in depth. Then what are the advantages of potentiometer over the voltmeter? Because we can use voltmeter also. So why we are measuring the voltage using the potentiometer? The thing is, the potentiometer is more sensitive than the voltmeter. The another advantage of using potentiometer is, in this we can measure both EMF as well as potential difference. While in voltmeter we cannot measure the EMF of a battery or a cell, as the voltmeter uses some current through the circuit, but the potentiometer do not use any current, and that's why we can measure the EMF of cell also using the potentiometer. Then the another advantage of potentiometer is it has high accuracy. So you can measure the voltages of order of 10 to the power minus 6 volt. So this is very accurate and very sensitive, and that's why we use this potentiometer. But you might see that in our regular experiments we use voltmeter. Why don't we use the potentiometer then? So it has some demerits or drawbacks. So the first demerit is it is not portable. It is not a portable device, so that we cannot carry it with ourselves, like we can carry voltmeter with ourselves. Then another demerit is that the direct measurement of voltage or the potential difference is not possible. What does this mean? You know the principle of potentiometer. We measure the length, we take the ratios, and then we compare the EMFs. So this is indirect method. We measure the length and then using some calculation we find out the potential difference. But in voltmeter we can directly measure the voltage, so we no need to have some calculations. So this is the demerit of potentiometer. Thank you.